Hello folks, welcome back to my GIS tutorials. Today we are going to talk about randomization. What do you need a randomization? If we have a large sample size, sometimes we need to randomize this. For example, if you have DEP inspectors want to randomly check the quality of drilling, for example, out of thousands of drill holes that we have in Pennsylvania, maybe they want to randomly pick few. Then instead of being biased, how do you select samples from a large population? Sometimes, let's say, pollsters use a random sampling to get a public opinion before the election, who they are going to vote for, and things like that. Sometimes we have a large sample size, and then we need to narrow it down because it's very difficult sometimes to deal with large number of samples. I'll give you an example. Recently, we did collect water depth samples on a reservoir here in Keller Reservoir. We had about 45,000 water depth on a small lake. That kind of biases the analysis along the path of the GPR track. So we wanted to thin out some of the samples. We wanted to randomly pick some numbers from there, some depth. That's another example. However, we don't want to always randomize the sample. We also want to maintain some subgroups within a large sample. For example, we will be randomizing in the exercise few minutes all the parcels, all the properties that we have in Clinton County, but there are many, many townships within the county. Each township has their own number of people who live there. So in randomization, we want to kind of keep the proportionality of the population from each of the township. And randomization removes the bias from the sampling. So here is a workflow that we are going to follow today. Initially, I have done some groundwork, some homework, upfront work, because to save some time. So ArcGIS, you can check out the attribute table, and you can clean up the attribute table with the samples that you don't need, that are not complete, for example. Then we'll be using a tool in ArcGIS to export the table as an Excel file. That's called the table to Excel. Once we have in Excel, then we can save the Excel data as CSV. That's the format that GIS likes the most. And then within CSV, we can use a function called randomization. And then after we randomize all the parcels in Clinton County, then we can actually uh, select from the subgroup. And after selecting from each of the subgroups, each of the township, for example, then we can push the data back into GIS through a join functions, because GIS can join attribute table to external Excel files. So then we can use this randomized data uh, as a visualization. And then eventually we'll do some network analysis on the randomized sample, meaning finding, for example, the best routes between the houses that we'll be selecting for a survey, for example. So as you can see in the first diagram here, Clinton County has 34,000 parcels, meaning 34,000 pieces of land in Clinton County. I'll show you in a second. Within those parcels, some of these informations are missing there. So I looked at all the parcel that has full address. There are about 25,000 of those. So I kept 25,000 records. They are good. And then out of 25,000, I wanted to do a study only in and around Lock Haven area. So Lock Haven area has several townships nearby, as you know, Castania, Flemington, Mill Hall. So out of 25,000, about half of those are in Lock Haven area, about 12,833 households in Lock Haven area. So if for a random sample, I want to choose 1% of these total household, total population, for my study. So 1% random sample would mean 128 household out of 12,833. So 128 I could choose randomly from this large number, but I decided to proportionately get samples from Lock Haven, Mill Hall, Flemington, and Castania. For example, out of 12,800 people, Lock Haven has 7,531 people, about 58% of the population. So, uh, for my random samples 128, 58% of this number 128 would mean 75 households need to be selected from Lock Haven area. Similarly, proportionately, I selected 38 households from Mill Hall and 8 from Flemington and 7 from Castania because their percentage of people living in those townships are very small, about 4 to 5%. So let's show you what I've done ahead of time. So here is a Clinton County map. Let me show you. This is just a Clinton County ortho photograph, meaning aerial photograph of the georeferenced. Here we have those 34,000 households. These are each parcel. Each polygon is a parcel owned by a certain person. And these are the 12,833 households shown in green here in Lock Haven and surrounding area, like Lock Haven, Flemington, Castania, and Mill Hall. And from that household, 12,800, 1% household that I selected for random sampling, that would be about 128 samples. So let's show you the Lock Haven and nearby area where they come from. You can see these are the samples. And if I look at just the Lock Haven University area, so this is our campus here. This is the main campus. This is the science center here. So we can see if you open this attribute table of the parcel data, I'll show you that it has a lot of information about 32,000 people. But the most important information that we need is the addresses, towns like the Lock Haven, Mill Hall, Castania, and so on, state, zip code, and property type. So residential or empty or commercial, for example, C. And you can clean all this information that you don't need. I'll show you, for example, towns. If I right click on this and sort uh, from small to large, you can see a lot of addresses don't have the town information or the state information or the zip code. So these are the ones that I kind of trimmed out. So once we do that, we can use a tool in Excel. Like if you search within ArcMap, just write Excel and hit enter, you will see there is a tool called Table to Excel. So that allows me to really export the attribute table of this parcel data and convert it into an Excel file, and where I'll be able to do all this cleaning up and randomization. So so I have done that. So let me show you here. This is some upfront work that I did, like cleaning up, for example, of this unnecessary address that don't have uh, full information. So here are this is the Excel format exported attribute table for all these people living in Clinton County. So out of this, I cleaned out people living in and around Lock Haven area. So as you can see, I cleaned up this attribute table quite a bit, removed unnecessary fields. So we are down to 12,833 records. in and around Lock Haven. So how do I randomize this? To do that, you can use a random function in Excel. So I will be creating the random field. So to do that, you just say equals rand first bracket and just close the parenthesis without writing anything in it. And if you hit enter, a computer creates a random number between 0 and 1. So it's completely random. And at the lower right corner, you see this little square there. If you double click there on that square, it will fill up the entire field for all the 12,833 records. It will assign a random number to each of these records. So you can see it just did that. So here, there for each of the household or parcel, now we have a completely random number. I always suggest that you highlight that random column, copy it, and paste it back as special value like the numbers. That way, it's not a formula. Then save it. Yes. Now, all of my data here are um, already sorted by town names. For example, Castania first, and then we have the Flemington, Lock Haven, Mill Hall, all of these. But each of them have a random number assigned to it. So now if I right click on this or highlight these random numbers and we use the data sorting function and I want to expand the sorting to the remainder of the fields and I want to sort by the random number because I want to make those random values from smallest to largest. In other words, I'm going to shuffle all the household addresses now uh, by the random numbers. So if I do that, so you can see now smallest random number is up on the top and a largest random number at the bottom 0.999, right? In doing so, however, I have completely randomized all my records here. You see now Castania or Mill Hall or Flemington, they are in random order. If I was just interested in selecting 128 household without any proportion to the subgroup, like for each of the cities, like uh, selecting about, as I said, 75 people out of 128 from Lock Haven because Lock Haven has a larger population, then I could simply select 128 household from here. So that would be down to 129, right? Because the first one is just the header. So that these houses, that could be my random sample out of all the 12,000. And I could just save this record as an attribute as an Excel file and then join it back to the attribute table of the parcel data and it would show which of the household I have chosen out of 12,128 household. But remember, we want to also add a little bit of proportionality to our sample. So to do that, if we right click here the cities, for example, and you go back to your data and sort by cities. So, and I want to expand it, and this time I want to uh, sort by cities name, A to Z. So that will put the city's name back in order, like Castania and Flemington, and then Lock Haven and Mill Hall. But their random numbers assigned to them are completely random. In other words, so let's say that now I know that I need to select only 6 households from Castania and 8 from Flemington and 75 from Lock Haven and 39 from Mill Hall, total of 128. So we can do that like this. Let's say I just select 6 from uh, from Castania, and go down to my Flemington, for example, and select just a 7 from there by holding down the control key, right? So if I hold down the control key and I select my 7 from Flemington, similarly, I can select 75 from Lock Haven and 39 from uh, Mill Hall. You get the idea. Total of 128 first of this each of these batches. Then I can save it as a separate CSV file with only the chosen randomized 128 sample, and then using our field ID like FID, feature ID, because we have the same field in the original attribute table of the parcel uh, shapefile, then we can join those and we keep only the record that matches, and that way we will be able to visualize those records 128 on the map from our Lockhaven area. Let me show that, show you that's how I have done just that. For example, you can see these are uh, in golden or yellow. These are all the parcels in Clinton County. Green are the with the Lock Haven and nearby addresses, and then red are the one that I have selected randomly. Let's zoom to that layer and show some of those things to you. So you can see these are the randomly selected households. They are scattered everywhere, a total of 128. Some of them are pretty small. That's why you don't see them. It's difficult to see them, for example. So you can see they are scattered everywhere. Each of these dot is a household. So that's how we can do that. So as I said, to do that, you can use the join tool. So I'll be using, for example, the join tool here, and then you can select a field which is FID field, feature attribute, feature ID, and I will be selecting at that point from my Lockhaven area random samples, Lockhaven area random CSV, this file right here, and I want to add that, and using the same FID number in both of this table and attribute table and the CSV table, and I want to keep only the matching records right here. So if we do that, if we validate it just to make sure that you're are doing it right, it says that I'm doing it right, and then if I join it there, so if you notice, now I have only 128 household that are selected from the total of the parcels. This is a new batch that I selected. So let's do that. So what I'm going to do now is going to just remove my first peak of 128. I'm going to make a new peak of 128. So by right clicking on the parcel, because out of the parcel shapefile, I chose 128 random. So I'm going to export this data, and I am going to um, give it a name. wherever you want to save it. For example, this is completely up to you. So I am going to call this random log haven. We can even say 128 random, and it's a shapefile, as you can see. And I save it, and I say OK, and it will ask me whether I want to add this newly created layer to the view. I say yes. So here, if we change the color to something bright so that we can see, out of 12,833, 1% of the household is from 4 townships. So let's show you the where they come from. So here they are. We can actually just uh, zoom in into the one area so that we can see them better. So you see that there are 128 of my houses that I selected through randomization. Next, I will do, let's say I choose one section of this Lock Haven area and assign someone, maybe a student, to go to this household to distribute a survey or a questionnaire. So next exercise I will do network analysis to show you, if I chose this number of houses, what would be the best route to take to hit all the houses in a shortest distance, shortest time, or a shortest distance. That will be next. All right. Well, thank you. I hope you enjoyed the process of randomization in ArcGIS with the help of Excel, and then putting the Excel data back into the attribute table of the ArcGIS parcel data, in this case, Lock Haven data. So here is, I want to see whether near our campus, we have also picked only couple of or three of the household randomly. All right, thank you.